Welcome. Please.
Thank you.
Thank you. Thank you for your visit. We are waiting somebody else?
Yes.
Oh, okay.
He's the president of Auburn University.
Yeah, I know.
Thank you for
Very pleasant for us to have you here.
Great to be with you.
Oh, thank you. Please take a seat.
No, don't worry.
Well, we are the robotics team of the Universidad Austral here in Puerto Montt. We are part of the computer engineer career, and we work in robotic and automation from 2004, about that year. Along that period, we are working in different projects, from all-terrain robot, 3D point cloud mapping with lasers. And we have a very sophisticated laboratory. We are very proud of our laboratory. We have all kinds of components and tools and equipment that the boys can use to build and use their own creativity to create new projects, new robots, or new automatization solution for the industry or for home and so on. So we have here a little show of the kind of robot that we are using. We have from custom robot, homemade robot for a specific task, and also we work with professional robotic kits like the bioloids or the humanoid that is there. And recently, from about a year ago, we started to work in lunar rover or moon rover for the Google X Prize contest. We are the only Chilean team that is working on that. And in Latin America, there are just two teams, one in Brazil and the other here in Chile. We are in charge of the robotic aspect of the mission. The mission is called the alicanto mission. And our rover, if you can see here, is called the name dandelion because the wheels, it seems something like the dandelion flower. It's a bio-inspired design. It works basically like the box legs that need a strong traction factor for terrain like the moon surface, which have a very specific condition that the rover must meet to be able to work properly on that surface. Of course, the concept have some limitation or tasks that we need to complete, like travel about 500 meters, send video, feedback to Earth, and stuff like that. But we also think in another kind of limitation, like our design must be able to recover from a tip over. It is very important that on all craters on the moon that it have a tip over the rover, and you can see it's a reversible, so it can be driven in this position or on the other one. It's the same on both sides. Yeah. Right now it have a Wi-Fi and antenna back, but it's not the definitive one. But also it can be driven in the opposite direction, but also it can automatically recovery from a tip over. It have a preferred direction, so because of the component inside, cameras and other sensors. But you manually can recover or automatically have a balance system. It is required a balance system in a two-wheeler robot. It's also one of the smallest robots on the competition. We also add a minimalistic design because we don't want to be too much hurry or worry about the mechanical components. So we have a little amount of mechanical parts. Right now it's a stage 2 prototype. From this prototype we want to move for a 3-stage prototype with more definitive components, and after that the final construction with the component that can support the space environment, vibrations from the launching, and so on. This is part of my robotics team, the body of the computer engineer career. We are working very hard. Next week we are going to show this in FIDAE 2012, which is the biggest aerospace event in Latin America. It's the first time that the university presents a project in FIDAE, and we are very proud to do it.
Congratulations.
Thank you. Thank you. The Google X Prize organization team is also very happy with the design. Most of the rover designs that are in contest are kind of traditional in terms of traction system, but we want to make something different. So we are part of that. There are other universities in Chile in charge of other aspects of the mission. Rocketry, in Concepcion, etc. That's what we want to show. I don't know if you learned some questions. Any questions?
Does it work?
Yeah, right. Sometimes, of course. It has some temper. So.
What's the advantage of this design over a more traditional wheel design?
Right. According to NASA summary, after the Apollo mission, where they sent in Apollo 15 and 17 two rovers, those cars like they seem like boogies.
Yes.
Yeah, right. One of the conclusions was that a traditional wheel design in a lunar surface is very bad. The dust elevate too much dust, the dust gets stick to different areas. This is one aspect. These spurs eliminate part of that risk. Because of the surface, you need a very efficient traction system. These spurs tend to traction better in dust, very fine dust surface. And these spurs, there are not the definitive ones. We are testing with different kind of components. We are thinking something more soft even. Can track very well on rock, lunar rocks. We are in a testing phase. We have very a big amount of volcanoes around, so we have rocks that are very similar to the one that are in. We are very happy with the results of this traction system. It's weird, I know.
Is this steel?
Yeah,
metal
right
steel?
now. See, yeah.
Yes, that's solar power.
Yeah, right. Yeah, they are working solar power panel. But we have a problem here because in Puerto Montt there is not too much sun. So there are working solar panel, but we most of the time plug a cable to charge battery because here is very strange to have this kind of sun. But in the moon there is no problem.
Is this a camera?
Yeah, right. The constant demand to send video in real time or soft real time with a little delay from the moon. And it has to storage a video in high definition, but not transmitting it in real time, just store it for download. So the robot need to have a FTP server or something like that. It's a full PC computer, embedded computer as a brain of the robot. So we have there Linux, we run open source software that do most of the job.
And the energy for move the wheel and everything is a battery?
Yeah.
And how many hours you can move the robot?
Amount of time moving?
Yeah.
In our test about 1 hour, at least 1 hour. But it can be more. It depends on the task. It depends on the surface. If you have some inclination, motor to the minimum power.
How steep an incline can it go?
So far about 12 degrees, but we want to add 2 more packs of battery. We have the space. The rocketry guys don't want, don't like that we add the component because it's more weight and the mission, all calculation need to be done again. But we are going to add 2 more packs and we expect about 20 degree inclination.
Okay,
Impressive.
So probably you want to test the robot in a landscape like very similar to the moon, right?
Yeah.
Do you know about the moon body in the Atacama Desert? in
Yeah,
Chile?
right. It's one of our tasks for this year.
Yes, the scientists at alicanto,
Yeah.
the university in Pittsburgh, they come to here to the
Yeah, right.
moon body with their robots
Yeah, right.
to test them.
They have a Mars surface and a lunar surface. So we have a little trip to the north to.
So you're going there? Test them?
Good, good.
We want to make more tests about that with the stage 3 prototype to be more precise on the experiments. One more thing. This is weighing just 3 kilograms. It's very light compared to the other rovers. And that's 3 kilograms on Earth, and the moon is 1/6 of that. So all the power that we see here is become more power, more fast, more efficient on the moon.
Okay, thank you.
Impressive.
Okay.
Yeah.
Felicitaciones, muchas gracias por el tiempo.
Thank you.
Bring home the visage. Good to visit.
Chao, te felicito. Chao.
Chao, gracias.
Thank you.
Yes,
Yeah, right. But not here. I can.
If you would send me an email, if you don't have a card.
Right.
One of my colleagues is involved, I'm a mechanical engineer, one of my colleagues is involved with similar work, and I'm going to put you in touch.
Excellent.
So please
I'm
send me.
going to send you a mail and you have my contact then.
Okay, very good.
Thank you.
Very nice.
Thank you.
Very glad to meet you.
Bueno.